Good morning to all. Today we will see the topic of electrical circuit analysis. First of all, what is meant by circuit? Circuit is a combination of active and passive elements. But active elements are called as all source elements called as active elements. Load element called as passive elements. The circuit, electrical circuit means it's a combination of active and passive elements. I already told that the combination of active and passive elements, where active elements are source elements. Example of source element is nothing but generator, transformer, or any voltage source. All source elements called as active elements, and load element like three types. We have told three types of load, that is inductive, capacitor, resistive. All load element called as passive element. Now, as conclude, electrical circuit means is a combination of active and passive elements. Next one, electrical circuit classified into two categories, that is AC circuit and DC circuit. While we are going to use AC supply means that circuit is called AC circuit. The AC circuits contain AC source and load element like resistive load, inductive load, or capacitor load. Similar that DC circuit is combination of, so it's combined DC source as well as DC loads. Like resistive, mostly DC loads, only on resistive loads. Here we are going to see only on DC circuit and along with resistive loads. Here, DC circuit basically DC circuit we consider only resistors, resistor combination of resistors, connection between two resistors, two or more resistors. So connection between two resistors is called, it's classified into three categories, that is series circuit, parallel circuit, and star network, delta network. Here, series network, parallel network, and star and delta network are network reduction method. What is meant by network? Electrical circuit means it consists only of one closed path, that is active element, passive element, as well as one closed path. It's called as electrical circuit. In case network means it consists more than one closed path. For example, here, electrical circuit and electrical network. Here is the example for one DC source, resistor. This is the example for electrical circuit. Here, in electrical network, contain more than one closed path. Here, we take one DC source. So this type of network, this type of circuit is called as electrical network. This is for electrical circuit, this is for electrical network. If your circuit or your network contains single closed loop grid, here is called as electrical circuit. More than one closed loop grid is called as electrical network. Here, next we are going to see about. Next we are seeing about voltage. Electrical voltage, nothing but electromotive force. That is called as a EMF. Where EMF is nothing but electromotive force. The electromotive force is energy supplied for unit charge. Electromotive force nothing but is electric energy supplied for unit charge. Here are work done on each coulomb of charge. Here the EMF told that EMF said that energy supplied for unit charge are work done on each coulomb of charge. What is the potential? Voltage or the potential difference, that is potential difference between 2 points, that is energy transfer per unit charge between 2 points. What amount of energy transferred from one point to another point is called as a potential difference. Always potential difference is measured between 2 points. The unit, both EMF or potential difference, unit is volt or coulomb by joules per coulomb. Both are same. The electromotive force or potential difference, both are same, generally called as voltage. Voltage or voltage difference. Here in electrical, we have two types of voltage. One is AC voltage and one is DC voltage. We have discussed only on, here we have discussed only on DC voltage, not for AC voltage. Each and every battery, it's a DC voltage source elements are, that is batteries. Battery is the best example for DC voltage source. So, battery energy storage device it used to store the electric energy in form of DC source or in form of voltage. That voltage is DC voltage. Next, resistance. Resistance nearby. Each and every conductor, each and every electrical conductor having some amount of resistor value. In case resistor value 0 means where the current is infinity, so each and every resistor, each and every conductor having some amount of resistance value. The statement of resistance nothing but it is oppose the conduction. Resistor is always oppose the conduction. So resistance is concept of proposed is resistivity unit is ohm resistance into L by A. Here that is you take any conductor, the resistance of the conductor nothing but rho L by A. L is length of the conductor, A is cross-sectional area, and R nothing. Resistance always denoted by R. Unit is ohm. Okay. So resistance in a wire nothing but rho L by A. Unit is ohm. Resistance always to oppose the current flow. Resistance always to oppose the current flow. Next one. Resistance network. Resistance network basically class in two categories. Resistance, that is resistance in series, resistance in parallel. Here, resistance in series where R equal nothing but that is R1 plus R2. Two resistors are series means the R equal resistance are R1 plus R2. Similarly, two resistors are parallel means the equal resistance 1 by R equal to 1 by R1 plus 1 by R2. Here, in series circuit, what is the current value? Current value is always same. Series current is always same. So here that is I into R nothing but voltage, supply voltage, I into R nothing but voltage. V1 equal to I into R1, V2 equal to I into R2. This is the formula for Ohm's law. This is based on Ohm's law. Here we discuss about Ohm's law. What is Ohm's law? Here, Ohm's law nothing but at a constant temperature, a current flowing to the circuit or current flowing to the conductor is directly proportional to the potential difference between the conductor. That is Ohm's law always voltage directly proportional to current. Here voltage nothing but a constant temperature, current flowing to the conductor is directly proportional to the potential difference between the conductor. Here we take this the conductor of current flowing conductor, here flowing current this side. The potential difference here V1 is a V2. Now according to Ohm's law, where V equal to potential difference V2 minus V1 or V1 minus V, that is maximum minus minimum. Here current flowing from always maximum voltage to minimum voltage. So V1 minus V2, it is denoted by V. Is V always directly proportional to flowing current? Here I is a flowing current. So according to Ohm's law, V directly proportional to I, where here I mentioned the word formula voltage equal to I into R, where V directly proportional to I. Now V equal to I into R, where R equal to Ohm's constant. Ohm's constant or other than called as resistance. Where R equal to Ohm's constant, other than called as resistance. Now according to Ohm's law, here according to Ohm's law, here we have to write voltage I, voltage nothing but V equal to I into R. Similar that voltage across resistance 1. Here, two resistor and series. That is R1 and R2. So V1 nothing but voltage across the R1. Or voltage in R1, V2 nothing but voltage in R2. Where total voltage equal to V. Now total voltage equal to voltage in R1 or voltage drop in first resistance. Voltage drop at first resistance plus voltage drop at second resistance. That is total voltage equal to voltage drop in load element 1 plus voltage drop in load element 2. Now according to Ohm's law, V equal to I into R equal to similar that V1 equal to here I equal to same because series circuit current is same value. The difference is R1 and R2, that is V into R1 plus I into R2, that is I is common, so R1 plus R2 for series circuit. For series circuit, R we know that voltage equal to I into R. Now I IR equal to I into R1 plus R2. I will be cancelled. Now R nothing but R equal the dot resistance equal to R1 plus R2. This the dot resistance are two resistors in series. Similar that two resistors in parallel. Now two resistors in parallel. This formula also based on Ohm's law, where you know that Ohm's law equal to V into I. Sorry, V equal to I into R. Now I equal to V by R. So here we take two resistors in parallel. This is resistor 1, resistor 2. Now in parallel voltage is same, current is different. So I1 nothing but current in R1, I2 nothing but current in R2. Now I1 equal to total current. Now total current equal to I1 plus I2. Now we know that again based on Ohm's law, I1 equal to V by R1 plus I2 equal to V by R2. Now where I equal to V by R, here V by R1 plus V by R2. Now in V by R1 plus V by R2, common is V, that is V by R equal to V into 1 by R1 plus 1 by R2. Now V will be cancelled. Now the total resistance in parallel 1 by R equal to 1 by R1 plus 1 by R. This is obtained based on Ohm's law. So in electrical, everything based on Ohm's law. Where Ohm's law nothing but V equal to IR, or I equal to V by R. Another formula based on using Ohm's law, formula and power equal to P equal to V into I, or I square into R, or P square by R. We are using three formula for power based on Ohm's law. Again, clearly I explained that. The electrical power equal to V into I. This is a general formula. In AC power, we class three categories. There is real power, reactive power, apparent power. Now we are discussing only on DC power. DC power will be into I based on this based on Ohm's law. Now based on Ohm's law, you know that V equal to I into R into I is a formula for power. Now I square into R. Formula. Either you are using P equal to V into I or I square into R. Or based on Ohm's law, you know that V into I, where I equal to V by R. Based on Ohm's law, I equal to V by R. Now V square by R. This is the third formula. So using Ohm's law, to calculate the power, either V into I, this is also based on Ohm's law. P equal to I square into R, or P equal to V square by R. R formula based on Ohm's law, it's applicable only on one voltage source series to the one resistance. Where Ohm's law applicable only for one voltage source series to the only one resistance. In case more than one resistance means Ohm's law not applicable. At the time, to calculate the R equivalent, either the two resistors are series or parallel. Maybe here it is series, here the three resistors are parallel. At the time, first to calculate the R equivalent, next to find the R equivalent means the circuit reduced, that is a voltage source. Here R equivalent V. Now R equivalent may be R equivalent equal to series parallel of R2, R3 plus R1. That is R2, R3 are parallel series to the R1. So this is the R equivalent value. that value may be is denoted here. Now one voltage source series to the one resistance. It now what ohms law is applicable. Now to calculate the total current, you are in total voltage value to find the total power either I squared power or V into I or V squared power. Which formula you got? Next. Now current nothing but flow of electrical charge or flow of free electrons or flow of charge particles. Current is nothing but flow rate of charges. Generally told current nothing but flow of charges. It's a general formula. Now it is denoted by rate of change of the charge. Here Q is charge, Q nothing but charge, here T is time. So electrical current denoted by I unit is ampere, that is rate of change of Q charge denoted by time. So rate of change of Q, that is rate of change of charge in small time interval. Rate of change of charge per small time interval, that is denoted by delta Q divided by del T. Here I give one example, that is 10 power 16 electron passing a point in every 1 second. So current equal to 10 power 16 electrons, that is charge particle passing in every 1 second. So current delta to find is the charge in each and every electrons. So the charge of electron that will be 1.16 10 power minus 19 coulombs, that is charge of 1 electron into 10 power 16 electron passing every seconds. So totally 10 power 16 into charge of electron divided by time. Rate of change of time will be 1 second. So finally we got the current value 1.6 milliampere. 1.6 milliampere, unit is ampere. Current always denoted by unit is ampere. Ohms already discussed. Now Kirchhoff's first law. Next, Kirchhoff's law. Kirchhoff's only have two laws. One is first law and one is second law. Kirchhoff's current law, Kirchhoff's voltage law. Here, Kirchhoff's first law, that is first law KCL, that is Kirchhoff's current law. Kirchhoff's first law, Kirchhoff's current law, that is the total amount of current in a node point equal to 0. Here, the total current entering the circuit or junction is equal to leaving the junction. Here we take this one node point or junction. So total current here small I1, small I2, I5, I3, I4, I6. Here entering current equal to leaving current. This is the node or junction. In a electrical circuit, a node or junction point, the total current will be 0. This one statement, or entering current is the leaving current, or some algebraic sum of entering current equal to algebraic sum of leaving current. Here I have taken for entering currents are I1 plus I2 plus I5. The leaving currents are minus I3 minus I4 minus I6 equal to 0. That is algebraic sum of total current will be 0. That is one statement. Here algebraic sum we take entering current is positive value, leaving current is negative value. Entering current or leaving current. We are going to another statement. Entering current or leaving current. Entering currents are I1, I2 and I5 equal to leaving currents are I3 plus I4 plus I6. This another statement. So first one, at a junction or node, total current will be 0, that is entering current or leaving current. Entering current plus or minus leaving current, we take entering current is positive value, leaving current is negative value. So total current will be 0, second one entering current equal to leaving current. This is Kirchhoff's first law. The application of Kirchhoff's first law is nothing but nodal analysis method. That is one type of network reduction method, nodal analysis method. That method we will discuss in next video. Next one, Kirchhoff's current law. Kirchhoff's current law or Kirchhoff's voltage law. second law Kirchhoff voltage law. So Kirchhoff voltage law nothing but in a closed circuit, algebraic sum of source voltage equal to algebraic sum of individual element voltage. Here there is one simple circuit. Total current is I, total voltage is V, where algebraic sum of source voltage equal to algebraic sum of individual element voltage. This is one statement. Or in a closed circuit or one closed path, total voltage will be zero. This is another statement. We consider this is one closed path. So in this closed path equal to zero. That is here voltage rise, here voltage drop. Voltage rise or source voltage equal to algebraic sum of source voltage and total voltage equal to zero. That is V nothing but source voltage, I1 R1 nothing but voltage drop across the load 1, I2 R2 nothing but voltage drop across the load 2. The total voltage will be zero. This is another statement. In a closed loop, total voltage will be zero. That is second law, Kirchhoff's second law. The application of Kirchhoff's second law nothing but mesh analysis method. In this method, using this Kirchhoff voltage law to find the current in different elements, different load elements. Current value, voltage value, or power value. Here Ohm's law, Kirchhoff's laws, and current division rule, voltage division rule. Here current division rule, that is CDR. Current division rule applicable only for two resistors in parallel. Okay. Here R1, R2, here total current. We take I1 is a current for R1, I2 is current for R2. Because R1, R2 are parallel, so parallel we have different current values. In case R1 are the same current means R1, R2 are series. R1 are the parallel means if the current flow is different values. Here I1 equal to, that is current is nothing but the total current divided into two parts. Here I is a total current. Total current divided into two parts. The two parts are I1 and I2. Now to find the I1 value, where I1 equal to total current into, to find the I1 means we take R2 is the numerator and total resistance R1 plus R2. Here nothing but in other format V into R nothing but voltage value. Voltage across resistance 2. I into R nothing but voltage across resistance 2. R1 plus R2. This also practically used only for first formula, that is I1 equal to total current into another resistance divided by total resistance. Similar that I2 equal to total current into R1 divided by R1 plus R2. These are simple formulas. Here two resistors parallel, R1 R2 two resistors parallel. To find the current in R1 at the time, R2 is the numerator. To find the current in R1 at the time, R2 at the time, R1 is the numerator. Here to find I1 means R2 is the numerator, denominator is common, both of them. Similar that voltage division rule. It is applicable only for two resistors in parallel. Here voltage division rule, that is applicable for two resistors in series. We take two resistors in series. Here current flow is I. So voltage across resistor 1 is denoted by V1. Voltage across resistance is denoted by V2. Now the formula for V1 equal to P1 equal to total voltage into R1 divided by R1 plus R2. Similar that P2 equal to total resistor of voltage divided by R2 divided by R1 plus R2. The only difference between current division voltage division means to find I1 means at the time you are using numerator is R2. Here to find the V1 means at the time you are using numerator same resistance. It says you are going to find the voltage, that is V1 means voltage along resistance 1. At the time numerator is resistance 1 divided by total resistance. Here total resistance common for current division rule as well as voltage division rule. Both are same. Yet the difference between I1 means numerator R2, that is current division rule. Voltage division V1 means numerator is R1, that is voltage division rule. So it is here voltage division rule is only for two resisting series. More than two resisting means this rule not applicable. Both similar that more than two resistors are parallel means the current division rule also not applicable. Some cases we are going for three resistors also. Current we are using three resistors for current division rule. But simple method two resistors series means two resistors. You are going two resistor means you are going to use two resistor means that is very simple for calculations. Next, another method is network reduction method. Star network and delta network. Practically, we are going to use for star and delta network for power transmission networks. Both star and delta network use only for power transmission. Where star network, three phase lines, that is R phase, Y phase, B phase. Three phase lines make a open circuit means it's called star network. Similar that three phase lines it make a closed loop means it's called delta network. R, Y, B, that is three phases R, Y, B. So we are using R, Y, B, these three phases separate. Now we are going to discuss only on DC circuits. At the time we take three resistors in open loop, it's called star network. Three resistors in closed loop, it is called delta network. Now we take power line to resistance line, that is so A, B and C, that is resistor RA that is connected between point A and 0. 0 is common point for both resistor RB and RC. Similar that we have power line to resistor lines. That is point A, point B and C. Here, resistor between point A and B. Here, resistor between RA nothing but resistor between point A and 0, 0 is A and O is common point for all. So we didn't note that. So we take RA, RB, RC here. Resistor between RAB, resistor between RBC, resistor between RCA. In practical purpose, we are going to convert either star network to delta network or delta network to star network. The conversion we are using some formulas because conversion is most important. If delta network is only for power transmission, that is long distance power transmission. Star network used for power transmission, very short distance. If star network or star network used for near to the load or near to the consumer. Delta network for power station to grid. Delta transmission for power station to grid. Star transmission for near to the consumers. Now star to delta formulas, delta conversions. Star to delta, X to see the delta to star. This is for star network. RA, RB and RC. These were given star network. Now to convert this star to delta, point A, point B and point C. The point A and B between distance value for RAB, B and C distance value RBC and C and A is RCA. Where now RAB equal to denominator, here A, resistor A is present, resistor B is present, the option distance are RC, that is for denominator. In numerator is common for R, that is RA into RB plus RB into RC plus RC into RA. This is common. Numerator is common. Similar that RBC. Here option lessons for RA is absent. So numerator is common, that is RA into RB plus RB into RC plus RC into RA. Similar that RCA into 2. The option lessons are RB is absent. In numerator summation of RA into RB, that is short form of. This is the formula for star network to delta network conversion. Similar that delta to star network conversion. Next we are going to see the delta to star network conversion. The formula is simple formula, the conversion and place of RAB. That is the place, the most important place of RAB and RBC and RCA. To find the RAB values, we got some numeric value. That numeric value where we are going to place, that is the most important. Here RAB means that resistor always in between point A and B. That is the most important. You are going to using formula to calculate some value. That value here makes is totally wrong. So RAB means that is the first point of the A and B is C. RAB means in between the place of A and B. So that RBC means in between place of B and C. RC and the place of C and A. That is most important. Next, delta network equivalent. Delta network. The delta network are that is A, B, C. Here RAB, RBC and RCA. Now to convert star network, here RA, RB and RC. It's common by two. Now RA equal to the parallel of RA, nothing but parallel of RA is equal to RAB and RCA. There is a parallel resistance. This RA, place of RA, place of RA in the parallel for RBC and RAB. Now denominator RAB plus RBC plus RCA. The difference between star and star to delta conversion and delta to star conversion means in star to delta conversion numerator is common. In delta to star conversion denominator is common. Similar that RB equal to parallel RB nothing but RAB into RBC divided by RAB plus RBC plus RCA. Similar that RC equal to the parallel of RC nothing but RCA into RBC divided by summation of RAB. Summation of RAB nothing but RAB plus RBC plus RCA. The difference between delta to star and star to delta means star to delta means numerator is common, delta to star means denominator is common. That is the difference. Now we conclude our class. Now we are going to discuss about what is circuit, types of electrical circuit, and Ohm's law, is resistor, what is resistor interactions, Ohm's law, Kirchhoff's laws, and series parallel, series of resistor in series, resistor in parallel, current is group, voltage is group, and star and delta network. We discuss only basic formulas. Next video we are going to discuss about some problems about discuss topics. So we will see you next video. Thank you.